And therein lies some of the problems. If AI-enabled SOP assistance, for example, is quite new, how do you define that in the terms of a request for information or request for a proposal? It's quite a challenge to the agency even to understand how to specify it, never mind procure it.
Welcome to At the Intersection. I'm your host, Jim Anderson, and today I'm joined by Simon Davidoff, former global digital leader in transportation at AECOM and former head of digital services at Siemens. He spent his career at the intersection of transportation and technology, which should make for a lively conversation. We're also thrilled that Simon's an advisor to Beacon and grateful to have his guidance as we build. Simon, welcome to the show.
Thanks, Jim. Great to be here.
All right, so I want to, I like to start things out quickly. I want to do a lightning round here. So I want you to give like 1 to 3 word answers to a number of questions. Favorite place you've traveled in the past year?
Puglia, Italy.
Puglia, Italy. Okay, great. At what age did you know that transportation was a part of your path?
What age? 30 years old.
30. Favorite hobby outside of work?
Road cycling.
Red wine or white wine?
Red.
Red. Title of a good book you've read in the past year?
The Waterman.
The Waterman, okay.
Yes.
Finish the sentence. AI is blank.
Sustainable.
Sustainable, okay. All right, so let's move on. You and I have talked a lot about life cycles and, sort of both in your AECOM days, your Siemens days, obviously in the world of transportation. DOTs talk about life cycles all the time. You plan, you design, you build, you operate, you maintain, you retire. Where does that thinking fall apart in practice across you sort of think about your entire career and then let's hone in on transportation?
Where does it fall apart?
Yeah.
Well, look, I think the connection between the design and the operation and maintenance is not so clear. It's becoming clearer with digital threads and digital twins, but I think if you like, the desk-bound design stage and the real-life operating stage is somewhat disconnected.
Okay. And let's talk about digital twins for a second. I love the concept of digital twins. Who wouldn't? But like in a world where we can never seem to get as-built drawings, is it realistic to imagine that we can get a digital twin that is actually, a high-fidelity representation of that which is in the physical world? Can that even be done?
I think it can be done, Jim. Yeah, I think it will take a lot of effort and innovation and willpower to put that into practice. But yeah, sure, it can be done.
Okay. I like your optimism. Let's go do it then, right?
The one thing I think, though, people sometimes overlook is the business case behind it. Do we really need a digital twin for, say, a bridge?
Yeah. Well, and that's a great point, because one of the reasons we don't have very good as-built drawings typically is because you get to the end of the project, there's not a lot of incremental economic value, or at least it's way delayed, right? Somebody 20 years from now may wish they had these as-builts, but if I'm trying to wrap the project up now and reconcile everything, that's sort of not necessarily an economic priority. So that's a great lens to look at it through. So let's talk about the systems, because that's another thing that comes up a lot, right? There's the business case, and then there's the systems and the technology stack. You're familiar with our TMC React product, which is incident response in departments of transportation, potentially transit agencies. But like when somebody's trying to think of incident response, the technology stack for that treats it like 10 or 12 separate problems, right? You've got an ATMS, and you've got Google Maps, and you've got radios and telephones and email and all those kinds of things. Like how do we end up at a world where you've got such fragmentation of technology? And then maybe the next question after that will be like, well, what are we going to do about that?
Yeah, well, we've got to get some sort of interconnectivity between the different platforms, the different use cases. I think the reason why, I know where you're headed, Jim, the TMC React solution pulls together that fragmented database of knowledge bases. And I think that's why it's so crisp and articulate.
Great answer. Actually, I'm not sure I could do any better than that. A great idea in theory. Let's see. You mentioned the business case, and I'll also talk about procurement, right? You've been around government agencies certainly most of your career, and you know that procurement is a big piece of the puzzle, right? If you can't procure it, if you can't have a commercial relationship, then it almost doesn't matter how good it is, right? At least not to your problem. And so, talk to me a little bit about the technical fragmentation and how much of that is a procurement constraint, the technical limitations, other kinds of constraints? Let's help bound the problem so that we don't just get so focused on the technology that we miss the broader point.
It's a very involved question, Jim. How long have we got?
2.5 hours. No, not really.
Yeah. Let's take the case of a transit agency where they are highly regulated in the way they procure, and they will need to specify a solution to the nth degree, it would seem sometimes, before they can move. And therein lies some of the problems. If AI-enabled SOP assistance, for example, is quite new, how do you define that in the terms of a request for information or request for a proposal? It's quite a challenge to the agency even to understand how to specify it, never mind procure it, which obviously is a piece. So I think we're back to the educational part of the equation where transit agency engineers and procurement need to get together to understand the problem in order to understand how to therefore describe it, to attract vendors to then bid for it, through the traditional procurement route. So there's sort of multiple dimensions to this emerging field.
I think that you just maybe answered one of the questions about why does it take government so long? Well, not only are procurement cycles long, but if you have to wait for the space to settle down enough so that you can define it, so that you can write an RFI or an RFP, so that you can then have bidders submit and be able to select. Almost by definition, you have to wait for the problems to all be solved, right? Or at least to be largely solved. RFI is a nice waypoint, but an RFI doesn't actually help you do anything other than potentially get to an RFP and understand the problem, right? So maybe it's an accelerant, but really, I mean, you're talking about it taking a long time. And in a world that's moving really fast, like artificial intelligence, it's a, what would the electrical engineers call it? I think an impedance mismatch, right? It's just, you got one set of things trying to operate at super speed and the other that's just not designed to operate at that speed, and it's going to create problems, right?
How do you shortcut that mismatch, right? I've seen work in agencies in the past, in my own experience, is piloting to somehow almost de-risk the procurement process so that you can understand, or the engineers who are wanting to take a little bit of a small technical risk and counter that risk by trying it first in a controlled experiment, even at asking the providers to say, provide an exhibition or a pilot at no cost, which I've seen in the past. That sometimes opens the door quicker if procurement at least put their contractual language around it, but it takes the money off the table. And maybe piloting, having transit agencies, having a sort of the recognition that AI is a little bit different and you need to experiment and pilot. Maybe that's the way forward and to shorten the RFI, RFP process.
It's interesting. So let's go down that path a little bit because I'm intrigued, by anything that speeds things up. Piloting is certainly a legitimate approach, and zero-cost piloting would presumably, minimize or eliminate many of the procurement barriers. But what that means is, especially in the world of AI, where engineering talent and just talent in general is quite expensive, you actually have to go out and raise a certain amount of money to say, hey, I'm willing to spend some amount of money on pilots to fund this because I know that it's a great solution and it'll be worth it in the long run. From a financial perspective, you're basically saying, okay, I need to be focused more on well-funded companies who have been able to raise capital so that they can deficit spend on pilots to prove the value so that they can then recover the cost of the pilot and everything else they're doing somewhere down the road. Fair summary?
Yeah. It is a fair summary, and it's a frustrating one. It's putting the emphasis, isn't it, or the risk on the external vendor, the innovator, the startup, which is a little bit potentially, you could say, unfair, but I can understand it in a very risk-averse transportation sector. And right, I don't really see any other way around it at this point in time until the maturity of AI-driven solutions and AI-enabled solutions starts to become a little bit more readily understood, let's say.
It may be the reality, at least in some places. Obviously our focus would be like, hey, can we do a paid pilot, right? And can we make it a small pilot, right? Let's not make the dollars be zero. Let's make the dollars be something. And coming from the private sector portion of my career, we did learn the lesson sometimes quite painfully that people tend to value what they pay for. And so if you give something to somebody for free, then oftentimes they just sort of, okay, I'll get to this whenever I have a chance. It's free. Obviously, if you're trying to have a partnership and a collaboration, if one side's urgently trying to make it work and the other side's like, I'll get to it when I have time, that's not a great recipe for success either.
That might be a door opener, or at least accelerate the doors opening, and the safety use case.
Yeah.
Things that are related to safety are perceived or are treated a little bit different in my experience. If you can align your use case and your solution to helping things become more safer for the general ridership public, then procurement has a slightly different flavor in my experience. It's strategically aligning the use case to the things that make the agency really tick and be successful, because it's not a profit organization. Their incentives are to increase public ridership and experience, and above all, safety. Do that safely. So that, TMC React is nicely positioned because it has that strong linkage to making things safer for the general public. I mean, the mayors of cities should be interested in this. Everyone should be interested in this.
Yeah,
right? It's almost a no-brainer.
That's a great point, actually, and I like the segmentation. I mean, the return on investment. I've done a lot of ROI analyses in my career, and for something like React, which addresses incident response, I mean, it is kind of an obvious thing. Hey, we spend a lot of time dealing with congestion and uncertainty and all the things around that, and everybody gets frustrated. We know the economic toll, and then even more pronounced is what you said is like if you can reduce the time it takes to respond to an incident, say on the highway, we all know that crashes and incidents are magnets for secondary and tertiary events. So the quicker you can sort of get that off the roads and get that resolved, if you can reduce your incident response time, then almost by definition, your safety is going to go up. The quantification part is actually not that hard once you understand and believe that, oh, wow, this is going to help us respond to incidents more quickly.
I'm just going to go down that road, if that's not a pun. Oh, it could be. But the measurement of the benefit, the quantification of reduced response times, and then all those secondary topics that are a little bit more challenging to measure. But I've seen one or two agencies try and do this. That's the reduction in secondary accidents that you mentioned, the reduction in the carbon emissions for standing vehicles in congestion, the actual monetary value of lost time and lost productivity of the general population being stuck in traffic jams and so on are all measurable, right? And that should be an eye-opener, I think, to the broader organizations that are interested in improving the life of its citizens, in effect.
Well, and you live in Atlanta, and I know the Atlanta Regional Commission did a study a few years ago. I don't remember the exact numbers, but it was something like, traffic and congestion in Metro Atlanta costs on the order of $4 billion a year in terms of lost productivity, everything you just said, carbon emissions, fuel consumption, but the largest piece of it being wasted time, right? And anybody who's ever been stuck in a traffic jam, and we all have, knows how frustrating it is. And, I've got a lot of things to do that I can't really do stuck in this traffic jam. So I intuitively think that resonates. And then, by the way, the frustration that rises, I'd like to think we all, behave responsibly, but we see that when people get frustrated and they're stuck in traffic, they start, exhibiting behaviors, aggressive behaviors. I'm going to just get off and drive down the shoulder and, do these kinds of things that are really quite dangerous in aggregate. And it's not surprising that when that happens, people start taking matters into their own hands and further bad things can happen.
What I found fascinating in this space is that there are many different ways of tackling this problem of congestion and safety. And you guys have got one big piece of that, but there are other innovations, vehicle connectivity, looking at the condition of roads or the deterioration of roads in real time, which could be a precursor to an incident actually happening. All sorts of different companies looking at this problem from different perspectives. And I know there's the notion of an ATMS, the Advanced Traffic Management System. It's going to be interesting, I think, to see how all these technologies do interplay. It's kind of going back to a point you made earlier about the interoperability of these systems and how the greater use cases can almost combine. And I think DOTs and agencies and even the railroads, they all need kind of help understanding how to leverage these technologies for the greater good, right?
Yeah, well, and it's interesting. Many people tend to think of incident response in terms of sort of like how fast is the vehicle driving to get there? Like if you're talking about an ambulance or police, then obviously how quickly can they get there? I think most of what we're talking about is after that point, right? I mean, the people have been cared for, the fire has been extinguished. Now what? I've got an overturned tractor trailer blocking 4 lanes of traffic. That's not an ambulance and that's not a fire truck. So okay, well, how quickly can I get a tow truck there? Oh, wait a minute, it's an overturned tractor trailer. It doesn't need to be a tow truck. It needs to be a crane or a heavy lift truck. I need to have properly positioned, properly compensated, properly resourced companies, private sector companies come out and be able to respond quickly. It's not necessarily just the speed at which the vehicle drives to get to the scene. That's a tiny piece, really. It's, knowing which vehicles you need, knowing what responses need to be done, knowing I need to reroute traffic, knowing I need to update the digital message signs. There's so many steps that need to be done. That's the giant information challenge that when you look at the people who are on the front lines trying to do that, I mean, it's a very difficult and daunting job to know, okay, here's exactly what I'm supposed to do according to our standard operating procedures as adapted to this situation under the pressure of real-time stress and traffic building up. Like, how can we do that quickly? It has almost nothing to do in the aggregate with the actual speed of the vehicle getting there, or not nothing, but very, very little to do with the speeds of the vehicles.
It's not so easy, but I don't think there's any choice but to go through in a systematic way to try and evaluate what makes sense, and also keep that sort of practical deployment piece front and center, which again is very much close to your heart because that's what you guys are doing, and that's why I'm so excited about it.
Yeah, and practical deployment and also speed of deployment. Hey, we can get you something up and running 30, 60, 90 days is quite different than to say, hey, we want to sit down and write a ConOps document that can then go through the full process, and 18 months later, maybe you've procured a vendor to get started, with it, much less done with it. And there's a phrase in software development that comes to mind here, premature optimization. Okay, if I'm building an app and I'm not quite sure how much usage it's going to get and how valuable it is, I don't necessarily need 5 levels of redundancy on my database architecture, right? Just whip something together quick and dirty to sort of make sure you're doing the right things, and that's really part of the foundation of Agile software development. It strikes me that doesn't go very well with a procurement cycle that values very specific definitions and performance standards and all of that. But I love your point about the sort of, just get going, map it out, figure out what you can do maybe most quickly, and then obviously make strategic choices, because if you've got 100 things you can do, could do, but you can only do 5 of them, well, then you obviously want to choose wisely.
Yeah, exactly. I mean, I can't say it any better than you just said it, Jim.
Okay. So let's move on. You do have a tremendous amount of experience in the AEC world, and more broadly, I'll just call that consulting. Folks who are actually going out and doing a substantial amount of the design work and really bringing the engineering talent to bear. So why is software so hard inside of a consultancy? More recently, like, what did you see inside of AEC firms, and why is it so hard for them to deal with software?
Well, they're not, first of all, Jim, they're not set up to be a software product development house. They've got very sophisticated and competent IT organizations, clearly. They're good at IT governance, cybersecurity, kind of risk-averse approach, perhaps. But developing software, not so much, in my experience. It's just too much of a burden, and it's not the core competence, let's face it. There's all sorts of things being looked at, but not developed. It's more like adopting and interfacing and automating processes, not necessarily writing code. I think that's where the line should be drawn. I think writing code for an AEC company, not so much, in my opinion. Leave that to the professionals.
Well, and it's interesting. It may be a skill set issue. I mean, if your workforce, the lion's share of your workforce is civil engineers, mechanical engineers, other engineers involved in the design process, not to say they can't do software development, but it is a different discipline, a different domain. And then that billing model, if you're used to billing by the hour, one of the interesting things about software, the theory is it almost never works out this way, is that you build it once and you sell it many times, right? And so then you can amortize the R&D cost across multiple clients. I mean, probably the best example of that is the Microsoft Office suite, right? For you or I to install Microsoft Office and to start using Excel costs Microsoft effectively nothing in marginal cost, but they've put billions of dollars in R&D into it, right? And so that's just sort of that's okay. I have my engineers working on the software. I'm going to bill those by the hour to the client. Some fraction of their hours? I mean, again, it just sort of becomes a contractual mess. And I think it goes back to your point. Wow, it is very, very different space. And so then back on the sort of consulting side of things, like, okay, if you're inside of a consulting shop right now and you're seeing all this AI and it's like, if I bill by the hour and like AI helps me have some percentage less hours, 10%, 20%, 50%, whatever you happen to believe on a particular task, well, that's not really a benefit as much as it's a problem, right? Because you now have fewer billable hours, or at least, you hope you can have those billable hours be focused on higher value tasks. But if the benefit of AI is big enough, like it's like, wow, instead of billing 100 hours, I might only bill 60 hours, which is great for the client. It's great for my efficiency. It's great for making us feel like we're solving the problem quicker, but it's not necessarily great for my revenue stream and the financial underpinnings of my whole agency model. Is that a fair conclusion?
Yeah, absolutely. And that's what I think the AEC industry is wrestling with, that freeing up of expertise and knowledge can be used either to do higher value tasks, as you mentioned, or do something or in an area that wasn't necessarily, or we didn't have time to do before. So look at new innovations, new areas of revenue growth that just weren't possible before. And that's what I was going back to what I was mentioning before about the AI roadmap evaluation. There was a bucket in that sort of efficiency, differentiation, capabilities and so on to growth. And that the growth was, can we do more projects, more of what we do today? So that's a way of replacing that lost revenue or those lost hours, or do something slightly different in a way that we hadn't really perceived before. So that's kind of an exciting transition I think the AEC industry is being faced with. And I hear that not just from AECOM, but also some of the players that you mentioned, Jacobs, WSP. There are some publicly available recordings of the senior executives talking about the exact same thing. And funny enough, they were heading towards, or some of the conclusions were, let's look at O&M a little bit more than we did before. Look at across the life cycle a little bit further. We've designed something, I don't know, an airport or a transit station. You then provide O&M services, not the bodies, not the hours, but the knowledge of the systems and the use cases and the intelligence to say that if you want to operate this more efficiently with your guys, these are the tools and the pieces that we can offer to make that much easier for you. That's
okay. That's a very fair,
kind of like a middle ground.
Yeah, fair distinction, and thank you for clarifying that.
I was reading an article just this morning about AI helping to predict failures in vehicles. And OEMs are getting interested in how to do that. It's the same question, isn't it? How, if you can take your car into a dealership based on its impending failure, therefore schedule maintenance is a nonsense. So it's a little bit of the same problem. It's a business model topic as well, right? Yep. The AI stimulates that question. Do we push this? Do we make money out of it? But what's that going to do to our traditional cash cow, so to speak?
And it's interesting, agencies are all wrestling with this.
One of the topics that doesn't seem to get as much airtime is the M in O&M, the maintenance part. When I was working for Siemens, and this is an Atlanta story, we modeled how the doors opened and closed on a light rail vehicle. We could predict if they were going to get stuck. If the motors driving the doors are beginning to show signs of wear, and the doors get stuck at a platform, the train stops, the passengers get frustrated, the train is delayed. Siemens innovation used machine learning, and it showed over time how as the door pushed open, there was a spike in current, and as it started to move, the current dropped away. The degradation of the health of the motor, driving the doors closed, stopping the train from moving, which I think is a fantastic use case to show in reality how you can advise your train operators. A little bit like I was saying before, you don't want to operate the trains, but you can actually provide services that will help the operators understand the condition of their systems And if there's an analogy to the condition of roadways and condition of bridges and so on, it's valid. But the maintenance part is a very clean definition of how AI can help, I think. It's less contentious in many ways. It's a little bit more kind of mechanical and scientific.
Yeah. Well, and I love that analogy. Operations and maintenance, we were just talking about, they're undervalued typically, or at least under-resourced. Is it just that that's the easiest money to cut?
It is a bit of a tricky topic. And we're kind of back into the way these things are procured. And quite often, especially in transportation, you'll see a segregation between the ops guys and the maintenance teams, and never the twain shall meet. It's a little bit like IT and OT, OT being operational technology. And a procurement quite often is a CapEx topic, whereas the ops obviously is an OpEx topic, and those budgets sometimes don't meet as well. So you've got all these kind of fragmented in-house systems and processes and budgets to overcome. So I guess as a business development perspective, you've got a couple of choices. One is to pitch at the top so that you've got someone who can see down into the organization. The other is the value proposition articulation as a total cost of ownership. That's a classic, in my experience, of sales tactic that has been discussed for decades, is if you can get your customer to not focus on the price of the widget, but how much of the widget's going to cost you for the next 30 years. Constructing a bridge in the AEC world might be 300 million, but you've got to maintain it for the next 30 or 40 years.
Yeah.
And it's a classic opening of the eyes of the decision makers to look at the bigger picture, which is not always that easy. It's almost a selling, positioning topic, other than amongst other things. That's one of the challenges here.
Yeah. Well, and as you said, the top-down thing, okay, start with the high-level executives or commissioners, directors, et cetera, and work your way to the people then who are more responsible. Is like, that's part of management and leadership, is how do I view across multiple disciplines and reconcile competing objectives? How do I manage CapEx costs and OpEx costs, just as an oversimplified version of that? You certainly would expect somebody at the senior executive level to have visibility and care about both. Although again, like human nature, like I can care about it, but I need to respond to short-term incentives probably more acutely than I need to respond to long-term incentives. That's the reality.
Yeah, in my experience in the transportation world, in particular, just the CapEx is the only thing that the RFP is dealing with. Spares and repairs and maintenance and operations of the asset that they're procuring is someone else's problem.
Yeah.
This
has been a great conversation, Simon, and we've tackled lots of hard problems. So really appreciate you coming on today.
Yeah, that's my pleasure, Jim. It's been great.
All right. So this is At the Intersection. I'm your host, Jim Anderson, and today we talked with Simon Davidoff, former global digital leader in transportation at AECOM and former head of digital services at Siemens. Stay tuned for further episodes where we talk to the leaders shaping the adoption of AI across transportation. Thanks.